Hey geometries, let's have some fun doing constructions. But first, your tools. This is a classic compass, very sharp point. It opens up and you can look at the different degrees that it's opened up. Difficult to lock in, difficult to use, not my favorite tool. Instead, this is my favorite tool. It's called a bullseye compass. So we have this nose here, and you can put that over your points. You can tighten and release your slide and lock in different distances. So I'll use both tools for you. The SOL will simulate the marks made by both of them, and the one that it gives you on TestNav will feel more similar to this. All right, I'll show you. Copying a segment. It sounds so easy and simple, but what this is, if I were to try to use inches to copy the length of a segment, looks like it's a little over 3, a little under 3, depending on where my dot is. If I were to try to use centimeters, we're at the mercy of my ability to look at those little itty-bitty lines. But if we talk about copying a segment using a compass, what we do is we give ourselves an endpoint, and I can call that A prime because that corresponds with my point A. I put my bullseye compass on that point, and I put my slider right over top of B. And by drawing that line, it shows that this distance between these 2 points has been locked in. And that distance is constant no matter what. We're not at the mercy of my being able to read inches, centimeters, or any kind of value that we give to this distance. Because each of these distances are the same, I know that the distance from A to B is equal to the distance from A prime to B prime. So I know that segment AB is congruent to segment A prime B prime, because this distance was exactly transferred over. And these pencil marks here are what guarantees that this space was commuted to this space. And we can say that these are going to be congruent, and we use this phrase by construction to guarantee that this and this are the same distances because they were both locked into this tool. If I were to use the old-fashioned compass, I put my sharp point on 1 and I make my compass mark, and I try to hold it steady with it not sliding around, and then I transfer that distance over here, making that same mark, and then connecting that line. The big kicker with the segment is the segment you're drawing on has always got to be bigger because you have to be able to mark and end that segment. All right, so let's talk about copying an angle. The first step in copying an angle is to give myself a base for my new angle and my vertex. So I'll say this is going to be B1. It'll correspond to that. I'm going to place the nose of my compass over top of B, right over top of that point there. And I'm going to adjust my slider so that it is somewhere, and it doesn't matter, I can pick whatever arbitrary distance I want. Whatever that distance is locked in, and I'm going to draw it again over here. So what's interesting is this distance and this distance are now the same. So my next thing is I want this mouth of this angle to match here. So what I'm going to do is I'm going to take this tool and I'm going to measure how wide the angle is open at this particular point. I'll put my bullseye right there on that intersection and draw an arc designating how far this distance is. So this distance here is only happening between these 2 points this far away. So this here that I locked in, and then this here that I locked in, do you see how we actually have 3 sides of a triangle? So when I go to connect this side of my triangle, I've guaranteed that these 2 distances, that these 2 angle measures are going to be the same. And here's what's really cool about this proof. I want you to think about what it is that I created. Here is a radius of this circle. And so this is guaranteed to be the same length as that. Here is my second side of my triangle, and I measured it so that these, again, sides are the same. This is a second radius of this circle that I've created, and this is going to have the same measure as this original side because they are both radii of the same center point on the same circle. So therefore, side, side, side congruence guarantees my triangles are congruent. So then CPCTC guarantees the congruent angles. So then I know that this angle is congruent to this angle because of side, side, side congruence. So in review, the angle marks that I made were, I picked any distance that I wanted, and I was able to draw that here. I translated that same distance over to this triangle, guaranteeing that these 1, 2, 3, 4 segments were all going to be congruent. Now I don't know where to draw this one until I measure this distance. So I'll change my compass and measure this distance here. And I'll translate that over to here and draw my arc. Kind of cool. All right, that's bisecting an angle. Are you ready to bisect a segment? So when we bisect a segment, we want to find that middle point, that middle place where I can draw. So what we're going to do is we're going to put our nose of our compass and we're going to stretch this out so that it's past what I think might be midpoint. And then what I'm going to do is I'm going to draw an arc above and an arc below my line. And I'm going to keep that same distance locked in, put my compass over with my bullseye on this end, and I'm going to again draw a mark above and a mark below. That will give me 2 points of intersection that I can then connect. Do a better job there. I can connect, and this point here is guaranteed to be the midpoint, and what I've just drawn here is a perpendicular bisector. This is guaranteed to be perpendicular, and these 2 segments are guaranteed to be bisected. And these two segments are guaranteed to be bisected. Now, if you're curious about why, let's talk about what I just did. I measured, here's my radii, and here's the same distance here. So what I want you to see that I was able to draw here, see if you recognize the shape. I know that the distance from here to this end of the circle and here, because these radii, all radii from the same circle are congruent, right? There we go. Do you see what shape is coming? Call it out if you see it. I transferred that same distance over. I didn't change the settings on my compass. So guess what I ended up with? Do you see it? This is congruent to this, is congruent to this, is congruent to that. Oh, hello, rhombus. And if it's a rhombus, doesn't it have perpendicular diagonals? And don't the diagonals bisect? So because I have perpendicular diagonals and because my diagonals bisect, I know that this point here is the midpoint. And I know that this line I've created is the perpendicular bisector. All right, let's talk about what's up next. Bisecting a line. No, you can't. You can't find the midpoint of a line, silly. In order for us to bisect a line, we need to create a line segment, and we can cut a segment in half, but never a line. All right, so that is constructions 1, 2, and 3. 1, copying a segment. 2, copying an angle. 3 is bisecting that segment with a perpendicular bisector. And remembering there's no bisecting lines. All right, your next video is going to cover your next constructions.